So in this video, I'm going to show you how to create the stamp handle part of your project. This is essentially something that will be manufactured on the CNC lathe out of acetal rod. But we need to draw out the profile, and we're going to use the software that you should all know by now, which is 2D Design, or as it's now called, TS Design. And using that sketch, we can then take it over to a bit of software called Boxford Design Tools, which works directly with the lathe, and that will generate all the G code to make the piece in the lathe. So on the screen now, we've got the diagram for the stamp handle. This is my design. Yours may differ slightly, but there's a few things that you would need to keep the same to make this work with all the other parts, the other components for the stamp. So firstly, the threaded end, I would keep all the measurements exactly the same. So that's the M6 threaded part, the 4mm cutaway just to the left there of the threaded part, and also the main width of the material, which we're going to use 24mm acetal rod. And secondly, I would keep the measurements of the length the same. So a total of 50mm, but the main handle just before you get to the shoulder of 41mm. And I'll talk you through why that is a little bit later. But yeah, it's quite interesting with regards to the domed part, the domed end. With the domed end, this is actually a two-part process if you've got a dome part of your design. So if I show you here on the screen, you'll see that there's the lathe would cut the first bit, which is the thread part and the side profile, and then it would part it off all the way across the end, leaving a nice flat end. And then essentially what you would do is turn that around in the lathe, and we're going to screw that into a little jig which goes into the chuck really nicely. And then you run a second program, which is the dome. And I'm also going to show you how to create that dome program as well. So that's the reason really why we would keep the measurements the same, because it just makes our jigs work and everything will work really nicely. So opening up TS Design, you should all be familiar with how the program looks when you first open it. It's a standard A3 document, and you've got these little dots every centimetre. What we're going to do is we're going to change the way that this looks so we can get it pretty much looking like what Boxford Design Tools looks like. It makes it a lot easier to design these kind of side profiles for the lathe work. So first thing we're going to do is in the top here, there's a layout button. It's the little blue box. So if we hit that, you can see that the document is at the moment a standard size and it's classed as A3, and that's where you would have picked all your like A sizes. But for this, we're going to make the document size the same measurements as our metal. So for this, if we go down to user defined and click on that, you can now input the X and the Y dimensions for the material size and the design guide. Design guide is literally just to help you on the screen, so I normally duplicate both of them in here. So with regards to the length of the material that we'll be using, we will be doing a 50mm billet by it's the thickness of 24mm. So I'm just going to repeat that in these boxes and hit OK. So now this box should be a very zoomed in version of the side profile of our billet, our bit of metal. We're going to change the guides now to give you a little bit more of a hand to drawing this profile out. So on the top right over here, where they've got a series of dots, that is your grid menu. So if you double click on that, you can change the spacing between where the dots were. So at the moment they're at centimeters, so 10mm apart. For this, we're actually going to be doing, let me just work this out, 0.5mm per dimension. I'll explain in a minute why we do that. Down the bottom here, there is a style, and I like to turn this down to lines for this process, and I'll make the color a light green color and hit OK. And now we should see 0.5mm grid all the way from the edges of our piece. So the reason why I chose 0.5mm spacing for this grid, it'll be a lot more clearer in a minute, but we're designing the profile on half of the piece of metal. So say if something was 24mm in thickness, we want to know exactly where the middle point is at 12mm. And by doing this from the middle point, we can just cut the y-axis in half each time. It'll make a lot more sense when we're working on it now. First thing we need to do is, because we'll be creating something called a DXL file, it needs a center line. So we need to put in where the center of our material is. So I'm just going to do a temporary line all the way down to 12mm, so I know exactly where that 12mm is. And then I'm going to draw a line all the way from the left side to the right side along that line. And I'm just going to delete that temporary one. So we've got a line that's directly halfway between that 24 mils. For a center line in a DXL file, we need to turn it into a dashed line. So by selecting it and hitting line at the top here, we can, where it says type, we can select a dotted line. Okay, it's basically going to draw a dotted line with a pitch of 10mm. So I'm just going to change that to 1, just so you can see the dots a little bit more clearly. There we go. So we've got a nice dashed line halfway through, and as I said, the DXL file will see that as a center line. Now we've got this layout actually drawn out, we can start drawing the actual piece that we're going to make. So for this, I'm going to select the line tool, and you can see it does actually jump to every other intersection of the grid. That's because I've got step lock activated. If I turned that off and activated grid lock, you'll actually see it goes to every single ½ mm. So I'm going to select grid lock for this, because I'm not going to be doing anything that's off of ½ mm spacing. So starting at this very right hand side edge, I'm going to start drawing in the M6 threaded area. We're not going to add the thread at this point. The thread gets added in Boxwood design tools, but I'm going to basically make a 6mm end shaft just at the end here. So I know that this first one is obviously 6mm in thickness, so we're only going to go up 3mm. Because like I said, we're only doing half of it. So if you imagine the other half being on this side, that'll be a full 6. So we're just going to do 3 on this side. That's it. And I'm going to come in just to make a point. The threaded section lasts for 5mm, so I'm going to go across for 5. Just making sure it's nice and straight. That's it. And then it goes to a thinner section, which is 4mm. So we're only going to go to 2 on this side. So it's 1 and 2. So it's only 1mm down. That's right. And that will go for 4 mils. That's 4mm. Then the shoulder of the handle goes all the way up to the end, so up to the top, and then there is a 2mm rim, so there's 2mm there. So like I said earlier, on the other end, where we're going to have a dome, we're not actually going to draw in the dome at this stage. That's going to be for the second program we're going to run. So for this one, we're going to actually just leave it nice and flat. If we was to do a perfect dome, it's a radius of 12 mils. So actually what I will do is I will do a line from this edge to this edge, just so I can know where my 12mm dome will end. Okay. So if my dome ends there, I know from this section to this line here, I can start doing my curved arc. So for this one, I normally pick the curved path tool, and I'm going to select just there, work out how far down it will go, and then tally it up just there. That temporary line there again, just as a reference, I'll delete it now. Okay, so we've got the shaft part, the threaded part, the shoulder, the curved part, and we just need to box this off now at the end. So I'm just going to go straight across and then straight down. So essentially this is all done. There's a few little tiny steps to do, but it's quite hard to see the profile of just obviously half of a side. So what you can do, if you select it all and group it, I use Control and G to group. You can then copy the file, drag it over down to this bottom half, and just flip it. So that will give you a really good view of what it would look like with both halves completed. By using this mirrored image, you can also just double check your measurements. So you can physically draw lines to lines just to make sure that your measurements are exactly what you need it to be. It's a great way of just double checking. Just make sure you delete them after that you've drawn these lines. For the actual DXL file, it won't actually work if you have this bottom section in the image. So I'm just gonna just delete it again, and now I'm gonna unlock it with Control, ungroup it, I mean, for this purpose. So Control and U will ungroup it as well. So we've got our lines separate. The last thing to do with this file before we can export it as a DXL file is all of these individual lines are separate. They need to be one continuous long path. That's excluding that center line. So what I'm going to do is select it all, but then deselect that center line so everything else is selected. And there's a great tool up in Edit. If you go down and find Make Path, or the shortcut is Control and H, it's basically saying, warning, the Make Path function combines selected objects into one path, and that's exactly what we want. So I hit yes, and it says Make Path Complete. So now, if I select one part, the whole thing is just one line, and that's exactly what we need. And now that file is ready to export. So to export this file correctly, you're going to go up to File and find the Export File function. And obviously find where you're going to save this piece. Just on the bottom just here, you can select a multiple load of different file types. And what we're looking for is the DXF file. So select that, call it something practical, so stamp handle. Okay, and hit save. And the most important part of this is the curved parts won't function properly if you don't highlight the split curves into lines. So I'm going to just select the split curves into lines. Everything else you can leave exactly the same. Just make sure you've ticked split curves into lines, otherwise you'll get part of it imported and nothing else will work. So then hit OK, and our file is exported safely. So we've just opened up Boxford Design Tools, and this is the screen that you'll be welcomed with. There's a few different things that this software does. It's a general piece of software that Boxford use for a lot of their different CNC machines, like CNC milling machines and CNC routers. But we're going to use it for the lathe in this case. So this first section is where you would create or draw basically your flat profile. We've done that in 2D Design because it's a program that you already know how to use. I have created another video where I've created the same piece using this software. So if you are interested, go and watch that one as well. This is where you can also open up saved drawings that you've done. After you've actually made a drawing, you create it. You create it into a program, a G-code program, and this is a way that you can actually open pre-existing ones that you've saved if you've already converted them to G-code. And there's other functions where you can edit the G-code as well. So for this one, we want to open the imported DXF file. So we're going to hit open on the drawing here. And at the moment, we've got the folder that we saved our drawing to, but nothing's there. That's just because the type of file, we just need to bring the drop-down box and select DXF imports. And there, you can see the stamp handles there. Click on that and hit open. It's brilliant. So this is a part where we just need to give it a little bit more information if it hasn't dragged the right bits of data from 2D Design. So first of all, it just says component information. So I might call this Year 12 stamp handle created by, I'll put Mr. Fay. The outside diameter, it's picked from our drawing, so that's fine. Inside diameter, that's only if you are working with a previously bored bit of metal or something like a tube that has a hole running through it. The length, we know it's 50 millimeters, that's fine, everything's metric, and the hole depth, we don't need to worry about that. And we're going to hit OK. So now you can see our 2D design file has been created in Boxwood Design Tools, and this is going to be a really nice way of quickly turning it into a G-code file to run on the lathe. Like I said at the start of the video, the threaded part isn't actually there. This is just a block of 6mm thick acetyl. We need a way of adding that thread onto this edge. So really nicely, if you right click on the line that we want to add the thread, there is a option there that says convert to thread. And this is where we can add in a bit more detail. So for a 6mm thread, the pitch will just be straightforward 1. Okay, so we're going to do 1 mil thread pitch, and then thread specification. You can have a left-handed thread or a right-handed thread. Left-handed threads are normally used in a process where you don't want it to undo whilst it's being used. Quite commonly, your pedals on a bicycle would be left-handed thread. So as you're actually turning the cranks and riding, the pedals won't just fall off. But for this, we just want a common right-handed thread. So we select right-handed thread and hit OK. Now you can see that the thread is visualized just on the edge here. And I know that's all to the right measurements for the M6 negative thread. The dotted line just to the side of the thread, that's a clearance zone. So when the lathe cuts the thread, there's going to be part of the tool that's sticking out on the side, and so there needs to be a little bit of clearance to that side. You can see in our file that actually the clearance just comes up a little bit short before our line, so we know we've got enough space there for clearance of the tool. Now we've got this drawn up, we are able to use Boxwood to give us a bit of a 3D representation of what it will look like. So if you go up to View on the top menu and go to Launch 3D Render, a window will appear, or it will get you to save the file temporarily before it throws up this window. It's spinning aggressively, so just press the letter F on the keyboard and it will just freeze it. I'm going to bring this up nice and large and drag around. And now you can see we've got the threaded section, we've got the thinner 4mm shaft area, you've got the nice shoulder which goes right up to the edge of the piece, then we've got the arc, and then the flat side, which, as I said, what we're going to do is a separate profile, and I'm going to show you how to draw that out last of all in this tutorial. But I'm happy with that, so we can shut that down. So before we hit process billet, where we would process this into some G code, I will just explain about one problem that we will hit. So if you imagine a cutter is cutting all this material away on a spinning bit of plastic, and it gets down to this end where it's going to do a final part off. At this 0 line, that's exactly where the chuck will be. So we don't want there to be any nasty cutting happening with the cutter that's going to go straight in and hit the spinning chuck. So we want to give a bit of extra space onto this end. Normally I round the number up, so at the moment we've got like 50 millimeters length. I would add another 10 mils onto there, so a nice round number of 60 millimeters. So if I go up to configuration here and go to billet data, when we go into billet data, we can enter the length and the diameter, etc. again, and make some changes. So where it says 50 millimeters length, we're actually going to go to 60 millimeters now and hit OK. I'm going to zoom out a little bit. And now you can see it's added 10 millimeters just on this end. So there won't be any crashes. There'll be a nice little bit of material before the chuck. Now we are ready to process the billet. So we go up to File and Process. Basically it's saying, if you haven't saved it already, it's basically saying I've made some changes, so do you want to save it? I hit yes. So then this little window comes up. This is where you get to add a little bit more data so the lathe knows what it's dealing with, even regarding material. So you've got a selection of mild steel, plastic or wax, and aluminium and brass. So each of these different settings will set the lathe up in different ways. So it'll do different depths of cut, different speeds for feeds and cutting speeds to match what's needed. So with something soft like plastic, which we're using, it'll do more of a chunkier, thicker cut, rather than say mild steel where it'll do very fine cuts, because obviously a lot harder material. So we hit plastic, we just double check diameter and then length's okay, that's good, and we're going to hit process. It's going to ask you to save the G-code file. I've obviously done a test before, so it's asking me if I want to replace it. I hit yes. So now it's going to run a program, and you're going to see it on the screen on the visualizer of all the cuts it's going to do. At the time it's doing this, it's writing all the G-code out at the top here. So you can see it's done its roughing cuts and it's done its fine finishing cut. It's clearing some material out with the parting tool, then it's got a left-handed cut going there. Thread cutting tool is doing the thread. Okay, and then it should be the final parting off with the parting tool, and then back to the original tool. So during all that time, it's written all the code out. As an example, to do all of that process, if I go all the way down to the bottom, so you've got 1,950 lines of code to make this to where it's at the moment. So you can sort of see the program was doing a lot there to create the code. But it hasn't thrown up any conflicts. It hasn't said, well, a certain tool couldn't get into a certain area. If we're all nice and safe with that. So we can close this one down. And you can see the little visual of our files come up in the middle, which means it's all ready to send to the lathe. So down in the bottom here is a manufacture little lathe button. You would click that to send it to the lathe, and we'd get manufacturing with this part. But like I said, we've got the other part, the domed part that we're going to create. So for that, we're going to go back to 2D design, and I'm going to show you how to create that now. So we're back over to TS Design or 2D Design, and I've got my file laid out exactly how I did before. But actually for the domed end, for this file, we're actually going to change the size of the document, because we actually want it to be a length of 41 for this one. This just allows everything to sit in our little jig in the lathe correctly, and it cut the right amount off. So 41. And as I've adjusted that to 41, I'm just going to change the length of the center line. There we go. Okay, so for the dome, it's going to be a straightforward curved line just from this end. I'm going to show you a nice easy way of doing that. So with regards to the arcs button just on the left here, if you press and hold it down, it'll give you a lot of different options. And we're going to go to the draw a semicircular arc locating endpoints. Okay, so as an example, if I was to draw from the bottom to the top, you can see it's going to draw a really nice arc to the measurement that we want. But I want it to be exactly on that 12mm arc line. So I'm going to use my line tool to find my 12 mils. So it's just about there. I'm just going to delete that one. And now I know where I'm going to drag from and to. Actually, if I make this longer, because we're going to do it from this bottom side as well. So now we're going to click that that arc selection that we made earlier on. So I'm going to find right at the edge of material. I'm going to click there and drag up to the top there. Brilliant. And then that first line, I'm just going to delete because we don't need that. Let's have a look. That's really good. And just one other thing, we're not actually going to need this bottom part again. So in the delete button at the bottom, if you hold and go over to the one that has a little red, two little red lines inside and select that, it means you should be able to go over to that other part of the arch and just click on it to disappear. There we go, and we've got the bit that we need up here. Last little amendment I'm going to make is just at the end of the arc, just here, I'm going to add just a straight line going for probably 2mm. It just helps things work a little bit more efficiently. Let me just double check where it goes to. It goes to there. Okay. So I'm going to go 2mm from that edge and just add another little line. So you can see I've added another little section on there. As before, these are two separate lines, so we need to make them as one. So I'm going to select both of them by holding down Shift and clicking both. And then we're going to go to Edit and then Make Path. Hit yes. And okay, so that's now one nice curved line with the extra 2mm line. We don't actually need to carry the line down to the end, so it does actually just end there. It's something we don't need to cut any of this, because remember our profile's down here, so it would just be cutting mid-air. We don't need it to cut there. So that is what we need. Obviously our two lines aren't grouped, which is good, and we can then save that as a DXF file. So going up to export file, we're going to call it stamp dome or stamp handle dome. Okay, just make sure we're at as DXF file and hit save. Split curves into lines again, really important we do that one, and then hit OK. Brilliant. Now over to Boxwood Tools. So we're back over it in Boxwood, and we're going to open up the dome file that we've just created. So we're going to find the DXF import and click the dome file. Okay, and we're going to call it stamp dome, created by Mr. Fay. Outside diameter 24. Yep. So in the length, it just says 14mm. Don't worry about that at the moment. It's only because we've only drawn a dome which was the 12mm radius plus the extra 2 little millimeter line. So don't worry about that at the moment. It says 14. We're going to hit OK with this one. And I'm just going to zoom out. So now you can see it's just got the doming part, which is the 14mm section, and exactly how we need it. For this, we're going to change now the length of the billet to the 41, because we want the 41mm length to make the jig work. There we go. I'm just going to make sure I don't draw anything else. Brilliant. We can do the launch 3D render again, so I'm just going to hit OK with that one. And you can actually see that it's just the domed end that we're working on. Absolutely fine. And knowing that we're at 41 and 24, we're going to process this one with the plastic and wax at those measurements. Hit OK. And you'll see it run the program again. So you can see it's created the file. Just to do the doming, that's 600 lines of code there. So you can see even to do something relatively quite simple, there's a lot going on in the background. I'm just going to hit the X to close it, and you can see now we've got the file up in there ready to set up in the lathe and send and manufacture it. So I hope that helps, creating an initial drawing in TS Design and then bringing it into Boxford design tools to create the actual G-code file to allow the lathe to work to manufacture the piece. If you do want to watch a video of me doing it all in Boxford, so actually the drawing in Boxford, there is another video available, so ask your teacher where that one is. And you can see that, but hopefully that helps, and I'm looking forward to seeing the results. Thank you.